Okay, let's do one last problem here. Example number 7. It says evaluate the limit as x approaches 1 from the right of the natural 1 over the natural log of x minus 1 over 1 minus x. Notice if we plug this in, this would be 1 over the natural log of x as x approaches 1, so that approaches 0. So my denominator would be getting closer and closer to 0, which would make the entire thing get closer and closer to infinity. Same thing with the second one. You have 1 over essentially 1 minus 1, but that's a positive number. So the denominator is getting closer to 0, which would make the overall fraction get huger and bigger and approach infinity. So this would be infinity minus infinity, which is an indeterminate form. Believe it or not, infinity minus infinity is not 0. It is indeterminate. We don't know the answer. Notice this is not in a form, so I'm going to say but can't use L'Hopital's rule. To use L'Hopital's rule, it has to be written as a fraction, as 0 over 0, or infinity over infinity. So what do we have to do? We have to make it a single fraction. How do you make it a single fraction? Well, let's just do some simple algebra. This is the limit as x approaches 1 from the right of, and here I have 1 over natural log of x as my first term minus 1 over x minus 1 as my first term. So I need to make a common denominator. I'm going to multiply the first term times x minus 1 over x minus 1, and I'll multiply the second one times the natural log of x over the natural log of x. When I do that, so I would be getting x minus 1 all over x minus 1 natural log of x minus the natural log of x all over x minus 1 times the natural log of x. Now, and remember I'm still doing the limit as x approaches 1 from the right of this. So this is going to be the limit as x approaches 1 from the right of, and then on top we would have x minus 1 minus the natural log of x. And on the bottom, we'd still have x minus 1 times the natural log of x. And let's look at evaluating this one. So if we evaluated this, this would be 1 minus 1 minus 0. So that's a 0 on top, right? And on bottom, it would be a 0 times natural log of 1 is 0, which is also a 0. So that gives us 0 over 0, which is our indeterminate form that we want. Now we can use L'Hopital's rule. So this equals, by L'Hopital's rule, the limit as x approaches 1 from the right of, well, what's the derivative of x minus 1 minus the natural log of x? So that would be a 1 minus a 0, and then it would be minus 1 over x is the derivative of the natural log of x, right? Okay. So let's keep on going. What about the bottom? What about the denominator here? So what's the derivative of x minus 1 times the natural log of x? We actually need the product rule. So that'd be the first, which is x minus 1, times the derivative of the second, which would be 1 over x, plus the second, which would be the natural log of x, times the derivative of the first. Derivative of x minus 1 is simply 1. Okay? So let's go ahead and clear this up a little bit, see if we can get some common denominators, clean this up. What can we do to make this look not so friggin' nasty? And my guess would be the best thing we could do is get rid of the denominators. And to get rid of the denominators, what we need to do is multiply everything by the common denominator. A common denominator is x, so I'm going to multiply everything in the top and bottom times x. And when I do that, that's going to simplify those terms right there. So I'd end up with x minus 1 all over. And then here I would have x minus 1 plus x times the natural log of x. So nothing I can factor out there, nothing I can do. Notice if I plug in x equals 1, again here I would have 1 minus 1 all over 1 minus 1 plus 1 times 0. So this would still be 0 over 0, which is still an indeterminate form. So what I can do is use L'Hopital's rule again. Okay? So if I want to use L'Hopital's rule again, let's see what we get. The derivative of x minus 1 is simply 1. The derivative of x minus 1 is 1 plus the derivative of x natural log of x. Again, I need the product rule. So it's the first x times the derivative of the second, which is 1 over x, plus the second, which is the natural log of x, times the derivative of the first, which is just 1. So we still have the limit as x approaches 1 from the right of this. So let's go ahead and clean this up. Those x's are going to simplify into a 1. 1 plus 1 is a 2. So what I'm ending up with is the limit as x approaches 1 from the right of 1 over, and I'm getting 2 plus the natural log of x. So what happens? Well, now we can go ahead and plug in that 1. When I plug in that 1, it would be 1 over 2 plus the natural log of x as x approaches 1 from the right. That approaches 0, right? 1 over 2 plus 0 is 1/2. So what did I get? By manipulating this multiple times, I was able to get 1/2 as my final answer. So again, as a review, what happened? We started off by realizing it is an indeterminate form, but not what we needed. So we got common denominators. Once we got a common denominator, we realized it was an indeterminate form that we liked. So we were able to use L'Hopital's rule, which is taking the derivative of the top times the derivative of the bottom. Be very careful with your product rule in the denominator there. And then what I realized is we could simplify that by getting common denominators of all 4 terms. This is just an algebra technique. Multiply everything on top and bottom by the LCD, which was x, the denominator, the only denominator. That allowed us to simplify, and we realized that we were still in an indeterminate form when we evaluated the limit. That allowed us to find the derivative yet again. When we found the derivative, we were able to simplify and evaluate, and then we got our final answer of 1/2. So, L'Hopital's rule can be really, really simple when you're dealing with polynomial functions. You just take the derivative of the top, derivative of the bottom, but it can also be more, and that's in the cases where you have things like 0 over 0 or infinity over infinity, when right out of the gate it's in indeterminate form, that you can use L'Hopital's rule. Those problems are generally more simple, but there's significantly more sophisticated examples where you're not in that 0 over 0 or infinity over infinity form. Things like 1 to the infinity or infinity raised to the infinity, okay? So those are the types of forms where you have to know more tricks. You have to either be able to take the natural log of both sides, or you have to be able to get a common denominator, or use trig to rewrite the function, or use algebra to rewrite the function. So I want you to concentrate on kind of, I would say, definitely should be at least one of those natural log problems on the test where you have to take the natural log of both sides, and then probably one of the other forms where it's you just have to do a simple manipulation with the trig or something like this problem where you had to get a common denominator, and then there'll probably be one problem where it's very, very straightforward, L'Hopital's rule. Okay, so look at for I would say one easy, one medium, and one more difficult on the test on this one. Okay, if you read the last one, again it says the indeterminate forms are 0 over 0, infinity over infinity. Remember, these are the only 2 forms that you can use L'Hopital's rule on, but you do have other indeterminate forms. Infinity minus infinity is not 0. 0 times infinity is not 0. 0 raised to the 0 is not 0 nor 1. 1 to the infinity is not 1. And infinity to the 0 is not 1. Now, all of these are indeterminate forms. That absolutely blew my mind when I first saw it in Calculus 1. I'm like, how can infinity to the 0 not be 1? Everything raised to the 0 is 1, and it's not the case. It's an indeterminate form. So you have to be careful, but there are some that we do know. For instance, infinity plus infinity. While we don't know infinity minus infinity, we do know infinity plus infinity is infinity. Negative infinity minus infinity is still negative infinity. 0 raised to the infinity is 0, and 0 raised to the negative infinity is actually infinity. So those are some of the things that we do know. Just be careful with those, okay? I want you to look at the next one as well. This happens all the time. People look at something like the limit as x approaches 0, e to the x over x. Notice if you actually plug this in, on top you would have gotten a 1. E to the 0 is 1, and on bottom you would have gotten a 0. And a lot of people try using L'Hopital's rule all the time. So they said the derivative of e to the x is e to the x, and the derivative of x is 1. So you'd have e to the x over 1, and the limit as x approaches 0 of e to the x would be simply 1. Well, that is not true. You cannot use L'Hopital's rule here because you are not in the indeterminate form 0 over 0 or infinity over infinity. So the most important thing about L'Hopital's rule is the first step always is show that you meet the criteria of L'Hopital's rule. It has to be 0 over 0 or infinity over infinity. Has to for you to be able to use it. Okay? says the reason that this application is incorrect is that even though the limit of the denominator is 0, the limit of the numerator is 1. That's the 1 over 0, which is what I already said. So, good luck with this section. Enjoy your homework.